The title of the conference is Homotopy Algebra and its application. So it's actually a generic name we had to find, almost to invent some name. The idea is that actually we wanted to bring people from different areas in, let's say, algebraic topology in a very broad sense. And mostly there are three kind of people and three theories which are developed or explained during this conference. One is quite old, it's called the rational homotopy theory. And this theory is really an example of what is algebraic topology, which is we try to understand manifolds, geometric objects, using algebra. And rational homotopy is like one of the most powerful, one of the really very powerful tool for this method. And actually, this conference is to celebrate the birthday of one of the important leaders in this field, and Jean-Claude is another very important leader. And then also we bring people working in areas which are much newer. And one of these areas is called calculus of functor, which is an idea which is maybe 10 or 15 years old. And another one, which, I don't know, maybe there is even not yet a name of this because it's so recent, but it's something which emerged from a proof of what is called a Mumford conjecture. So that was a conjecture very important in geometry, in algebraic geometry, and using method of stable homotopy theory, Madsen and Weiss, following work also of initial work of Ulrike Tillmann, came with a very new approach to this problem of algebraic geometry. And algebraic geometry is really a field quite very different from algebraic topology. And starting from their proof of the Madsen-Weiss theorem, they've developed tools which seems to be extremely useful now, for example, to understand very algebraic objects like automorphism of the free groups. So there is Galatius, who is also here, who is becoming one of the leaders in this field. And so there are people like that, and also people using this technique which is called calculus of functor, which was developed initially by Tom Goodwillie and also by Michael Weiss. And so what is calculus of functor? So calculus of functor is a very strange idea. You want to understand spaces, like which can be very geometric, like spaces of embeddings of a manifold in a given space. And in a sense, you can decompose functors which express the space you want to understand, like a Taylor series. So you have Taylor series in calculus, right? And surprisingly, we in some sense can decompose a topological space or a functor of topological space exactly the same way you can express a function as a Taylor series, which is sort of an infinite polynomial. And so these three different techniques, so Madsen-Weiss and Galatius and Tillmann theory, calculus of functor of Goodwillie and Weiss, and then rational homotopy theory. And so the people were giving talk to each other. It was very obvious that each of these subjects can bring a lot of things to the other. And actually, already in the talks we had during the conference until now, we've seen that there are already many connections which appear, and obviously this interaction can only become more and more fruitful.